Hello friends, I am Dr. Sarika Panwar. I welcome you all in the video lectures of Information Theory and Coding Technique. Unit number 2 is Linear Block Code. In Linear Block Code, we have to study the different channel coding techniques. Linear Block Code is one of the channel coding techniques. We know that in communication, first we do the source coding, which we have discussed in first unit, and after source coding, before transmitting the data on communication channel, we do the channel coding. Now, why this channel coding is done, that we need to discuss first. We know that the desirable characteristics of any digital systems are high data rate, then minimum signal power, and highly reliable transmission of data and minimum bandwidth requirement. But in practical communication channel, these characteristics may get affected due to the noise, and this noise is generally added here at the communication channel. If we try to minimize the effect of this, we have to reduce the effect of this noise. Now this noise may corrupt the signal which is traveling on the communication channel. If we are transmitting logic 1 at the source side, it may be received as logic 0 at the destination side due to this noise. So, due to this noise, the reliability of data transmission can be severely affected. So, in order to improve the reliability of data transmission, we can increase the signal to noise ratio. This is signal to noise ratio, that is the ratio of EB by N0, where EB is the signal power and N0 is the noise spectral density, that is a noise power we can. If we increase the signal strength, transmission power will also increase, and there is always the limitation on the transmission power. So we cannot increase this ratio EB by N0 beyond some specific limit. There is some specific limit for this ratio. Beyond that limit, we cannot increase this ratio also. So how to achieve the reliable transmission then? So that we can do by using the channel coding technique. So there are some channel coding techniques available by using which we can detect as well as correct the errors which may occur due to the noise on the communication channel. There are some error detection and correction techniques available. Linear block code is one of that. Exactly what we do in channel coding, if these are the message bits, in order to keep the data safe from noise on communication channel, we add some parity bit in the data and we form the code word. This actually we do in channel coding. So for the detection and correction of the error which may occur due to noise on communication channel, these extra parity bits are added with the message bit at the time of transmission. These bits are called as either parity. These bits actually allow the detection or sometimes the corrections of the errors. However, they do not contain any information. These parity bits do not contain any information. Hence, they are also called as the redundant bit. They do not contain any information. The data bits, the message bits, along with these parity bits forms the code word. The decoder on the receiving side has the exact opposite function of decoding. So we encode here at the transmitter side. At the receiver side, what we do? We separate the message bits from the parity bit. And we know that this parity bit does not contain any information. So with this message bits, we have to transmit the parity bit just to keep the data safe from the noise. So with the increase in number of parity bits per code word, the accuracy increases. The accuracy of the data increases, accuracy of this message bits increases. But as we are increasing the total number of bits in this code word, the bandwidth requirement goes up proportional. Bandwidth will obviously increase. Why? Because message bits are suppose 4 bits and we are adding 3 parity bits. Then the total code word will become 7 bit if this is of 4 bit and this is of 3 bit. 3 parity bits are added in each code word, and this parity bits doesn't contain any information. But still we are adding it just to keep the data safe from noise. So we are making our data safe. We are making the system reliable ultimately, but at the cost of increased bandwidth. Before actually starting linear block codes, first we will see the types of error control techniques. There are 2 types of error control techniques. First is error detection technique and second error correction technique. The error detection techniques, these techniques are capable of only detecting the errors. They cannot correct the errors. Whereas the error correction technique are capable of detecting as well as correcting the errors. Now we will see the types of errors. The errors introduced in the data bits during their transmission can be categorized as content errors and flow errors, flow integrity error. The content errors are nothing but the errors in the contents of the message. For example, 0 may be received as 1 or vice versa. Such errors are introduced due to noise added into the data signal during transmission. Then second is the flow integrity error. Flow integrity error means missing blocks of data. It is possible that the data blocks may be lost in the network, possibly because it has been delivered to the wrong destination. Complete block of data may be missing during transmission. Depending on the number of bits in error, also we can classify the errors in 2 types as single bit error or burst error. In single bit error, suppose we are transmitting 0 1 1 1 0 0 1 1. So there may be the error in single bit like 0 1 1 1 0 1 0. So this last bit 1 is received as 0. So there is only 1 bit error. This bit is in error. Whereas in burst error, there may be the error in more than 1 bit. So if 0 1 1 1 0 1 1 is transmitted, it may be received as 0 1 0 1 1 0 0 1. So here we have transmitted this 1 which is received as 0 here. Then this 1 is correct, but this 0 is again received as 1. This 0 is correct. This 1 is received as 0 again. And this 1 is correct. So there is an error in 3 bits. So this is the burst error. So in error correcting technique, what we do, there is one data source which emits the message bits. These message bits are encoded by using this channel encoder, and the check bits or parity bits are added. Then it travels on the communication channel. This is the communication channel. Now at the receiver side, when we decode the message, we separate the data bits from the message bits. At the destination, only message bits will be received. So that is the general error correcting technique. But with this error correcting technique, we are increasing the transmission bandwidth because we are adding this extra check bits, redundancy bits. So ultimately it will increase the transmission bandwidth, and that is the disadvantage of the error correcting technique. Okay, now error correcting techniques are classified as linear codes and non-linear code. First we will discuss this linear code. These linear codes have got one very important property, that is, if any two code words are added, if C1, C2, C3, these are the code words suppose. So if any two code words C1 plus C2, if these two are added, we should get the third code word, that is C3. Okay, so this is very important property of this linear codes, that any two valid code words of the linear code are added, it will produce a third valid code word. These all three are the valid code words. And non-linear codes, this non-linear code does not exhibit this property. That is the important property of linear code. Very important properties of linear codes we will discuss. First, these are the four properties of linear codes. The sum of any two code words belonging to the code produces another valid code word. This we have seen here. If C1, C2, C3, these are the three valid code words, then addition of any two code words, any two, we can add C1 plus C3, we should get C2. Okay, so like that, we can add C2 plus C3, we should get C1. So sum of any two code words belonging to the code produces another valid code word, that is first property. Then second property is the code word with all elements equal to 0 is called as all 0, and it is always a valid code word. So if it is a 7-bit code word 0, 0, 0, 0, 0, 0 and 0, means all 7 bits are 0, then this is also a valid code word that we call the all 0. Then the third property is the minimum Hamming distance between the two code word is equal to the minimum weight of any non-zero code word. Now what is the meaning of Hamming distance and weight of the code word, that we will see now. Okay, and fourth property is the difference between any two valid code word will produce another valid code word. So we have seen that addition of two code word will produce third valid code word. Similarly, the difference between any two valid code word will produce another valid code word. Okay, so that is, these are the properties of linear code. So based on the functioning, codes, error correcting codes are also classified as block codes or convolutional codes. Okay, so this difference we will see afterwards. Now we will see the basic definition or basic terminologies related to the channel coding. Okay, so see, consider that these are the data bits which we have to transmit it. Having length k, we will add the parity bits in this. So if n is the total length of the code, then parity bits length will be n minus k. Next term is the code rate. The code rate is defined as the ratio of the number of message bits k to the total number of bits n in the code word. In this code word, n are the total number of bits and k are the message bits or data bits. So its ratio is nothing but the code rate, that is represented with small r. Next is Hamming weight of the code word. Hamming weight of the code word is nothing but the number of non-zero elements in the code word. Now consider that our code word is 1 1 0 0 1 1 1. This is our code word. So this is of 7-bit. So if we have to calculate the Hamming weight of this code word, then it is nothing but the number of non-zero elements in the code word, and that is 1, 2, 3, 4, 5. So Hamming weight of this code word is 5. Hamming distance. Hamming distance is always calculated between the two code words. Now consider these two code words, code word 1, code word 2. Now how these two code words differs? These differs in first bit, second bits are same, third bits are differing, fourth is same, fifth is differing, sixth is same, seventh is differing. So the Hamming distance of these two code words is equal to 4. This is how we find the Hamming distance. One more very important parameter is there in block codes, that is minimum distance, which is referred as dmin. Dmin is equal to the smallest Hamming distance between any pair of the code vectors in the code. In error correction, actually there are two techniques: forward error correction and automatic request for retransmission. Automatic request for retransmission is also called as ARQ. In ARQ, what happens when the data is transmitted? In ARQ, when the data is message bits are transmitted from the transmitter to the receiver, and if receiver finds that there is some missing block of data, then it may request for retransmission of that particular block of data. So that request will be transmitted through one feedback path. This we can call one feedback path, through which this receiver will give the feedback to transmitter that particular block of message has not been received. Okay, so after receiving the feedback from the receiver, transmitter may retransmit that block of data. That is what happens in ARQ. But in forward error correction technique, as such there is feedback. So retransmission of the data is not possible. Retransmission of a particular message block is not possible in forward error correction. So if error occurs, that has to be corrected at the receiver side. Thank you, students.